Hello and welcome. My name's Eric, and today I will be going over how to make a simple state machine using GDScript, as well as an example of using it in a game. This state machine will be used in future tutorials and is very generic. It can be used with UI, AI logic, and player movement. So let's check it out. We can think of a state machine as a class. That class will hold a list of possible states the state machine can run. The state machine can only run one state at a time. The core state machine's job is to simply handle executing the current state, as well as switching between different states if it's asked to. So let's think of a platformer character. That character can run, jump, and take damage. Now, taking damage or a hurt state, you may not think of very often, but it's actually a good example because when the player takes damage, things should happen, like playing a certain animation, firing off some effect, and potentially you may want your player to not be able to take damage for a few frames after taking damage. This example could be seen in most bullet hell games. Little details like this can help your game feel a lot better, and even though it's technically not fair, it actually makes your game feel more fair to players. These states will actually inherit from a base class, and through that base class, we'll get some methods to override: start, update, and exit. Now, when a state gets selected as the current state, we'll first check to see if there is already a state running, and if it is, we'll call its exit method. Then, we will call the start method of the new state. When start is called, it will emit a signal. We'll get into these signals/events later, but in short, other classes and their methods can listen to whenever an event is being fired. For example, you could have an animation class that's listening to the hurt state, and it can play the hurt animation just by listening to the event. Because of this, the player state machine doesn't have to worry about animations or sound effects. You can completely separate those things into generic nodes. Next, using Godot's physics process function, we'll call the current state's update function, and we'll run the update function until that state asks the state machine to change to another state. Now that we've talked about the idea of a state and state machine, let's jump into Godot and look at some code. Okay, so let's take a look at our simple state class. Okay, so first we need to extend the node class. Then we will name our class. That way it will show up in the editor easier. I'll show that here in a second. Next, let's declare our signals. So what we could do, clicking in the scene here, is Control A. I'm going to bring up this node search. And you could type in the name of scripts or nodes that are built into Godot. I have simple here, so we'll click. And that's what name_class will do for us. It will let us be able to add nodes that way, instead of having to add a node and then right click, add script, find it, drag it in there. It's just a little bit quicker sometimes. Okay, with this selected, probably see the inspector first, but you'll click on node, and then you'll be given these options of all the events. Now you can see there's some events here that we didn't declare, and that's because there's a object class, there's a node class that we're extending, and that node class has some events, and you may want to listen to those as well. But let's talk about the ones that we made. So how we can connect this event to a function or a method in another class. Click on state start, and let's say whenever start happens, I want to give my player some money. I don't know why, but hey. So we'll click on wallet, and there is a function in wallet called earn. So you need to type in the method name, and if the method has any variables, you should go over here and declare those variables. Give our player 100 of something. And then we can hit connect. I'm not going to, but you should hit connect if you were trying to connect this. And then every time start signal was called, it would call that function on the wallet, which is pretty nice. Now let's continue with the code. Let's talk about the class variables. Okay, so we have these two booleans, and they're here so that we only call start and the update signals once per each time that state is selected. So let's say that we say change state to the hurt state. We call start once, then once start's called, we call the update signal. And after that, we don't want to call those two until the player gets hurt again and we go back into the hurt state again. So that's when we have those. We have a reference to our state machine, and you could use this to call the change state function, which we'll talk about here in a bit. Okay, let's talk about the onStart method. OnStart method is going to call the signal. This does work. Just be careful when you're typing in your strings. Here is our onUpdate. Now this onUpdate should only be called once. At least how I have mine set up. If you want onUpdate to be called every time that update's called, you could change this a little bit. It won't be very hard. But I just like it being called once because that saves a little bit of performance. And when I'm using signals, I'm like notifying other classes that something happened. If I want to tell another class something in an update loop, I would just get a reference to that class. Now for that update loop, here we go. Update state. Now I'm going to call this through the physics_process method that Godot gives us and pass in the delta time. And this class you should override, or sorry, this method you should override and fill in like your own movement code or things like that. That being said, you don't have to override this. You don't have to do anything in any of these methods that you don't want to. So if you're using states for UI, you may not have anything in the update if you're just waiting for button clicks. So you don't have to use it. And lastly, we have our onExit method. And I don't think we talked about this before, but onExit has this underscore next state. And that's just going to be the name of the next state that you're going to. Now, this is nice because, well, let's go back to the example of you're a platformer. Let's say your character gets hit while running. Well, maybe there's a slightly different animation you want to play if that character gets hit while running versus if they get hit while, I don't know, standing still. So the idle state might want to know, hey, I'm going to hurt next. Or the motion state may want to know, hey, I'm going to the hurt state next. So those are nice. We also are going to reset these variables back to false so that if this state gets called again, the onStart will be called and the onUpdate will be called. Okay, so now let's talk about the state machine class. So we're going to declare some signals. I don't always use these signals in every state machine that I make. I'll just show them here. So we have a pre-start signal, a post-start signal, pre-exit, and post-exit. These are fired after every state, or before every start state. And they're useful sometimes. One example of when I really like them is with UI. All of my UI in this game is in one state machine. And when I go from one state, let's say the main menu, to the options panel, I have it fade to black and then kind of fade back in. And I handle that using this pre-start and post-exit. But I will say you definitely don't need these in a state machine. It's just something that's kind of optional. So we have a list of the states. We have a current state, the last state. We have a reference to the current state. Now, the reason that we have this last state is sometimes when you are in this state machine flow, you go into a state and then right after you get into that state, you want to immediately turn around and go into the previous state. Going back to the example of a platformer, when the character gets hurt, you may want that character to go to the hurt state. And then once the hurt state is finished showing its animations and whatever effects you want to play there and dealing damage, that kind of stuff, you say, hey, what was the previous state I was in? Because maybe you were hit standing still in the idle state. Maybe you were hit while in motion in the moving state, or maybe you broken out jumping and moving separately, so you were hit while in air in the jump state. These kind of things. Now, you don't have to go that far and then break things out that far, but if you did, it would be good to know what the previous state was so you can just go right back to it. Sometimes I keep a stack of previous states, not for this state machine, but in one that's a little more advanced. That way I have a longer record of what I've been doing and can just like roll back really far. So here's our ready function. In the ready function, we're going to check to see all of our children underneath this state node. And I'll show you this here in a second. And we're going to say, hey, if that's a simple state, then we're going to add that to our list of states. Yep, so here's our physics process where we call our current state, call its update state, passing in the delta time. Okay, just be sure you check to see if the state is equal to null and return. Because you may have noticed, this is a base class, so I didn't want it to automatically go into a state. You could do it that way. You could say, hey, okay, I have to do this for loop. Whatever the first state is, we're going to make that be the current state. So you could do that. And I have done that before in State Machine. I'm going with letting the derived class determine when it should go into the first state. Okay, so let's look at what setState will do is it will take the object that you passed in, that should be a state, and it will take in an optional message here. It's going to first do a sanity check and make sure you didn't pass it in null. And if you didn't, we will see, hey, is there already a state running? Okay, if we are already running a state, let's call the pre-exit. Let's call the exit of that state. Let's tell that state the name of the new state that it's going to. Like we said earlier, you may want to do something different. Call post-exit. And then we'll go down, set the string last state equal to current state, that current state equal to what's going to be the current state's name. And then we're going to set the variable state equal to the state that we passed in. And let's call start. So here we're going to first emit the pre-start signal. We will call start, we'll pass in the message. Now, I haven't gone into what this dictionary is, no message. We'll get into that at the very end. I don't want to bog us down too much. We're passing that in, and then we'll call post start, and then we'll call our on exit, which we'll call, not on exit, we'll call the on update, which we'll call the on update signal in the state. What you'll be using most of the time is change state. And change state, you could pass in a string of a state name, and it's just going to loop through all the states in the list, find that, hey, we found the state that matches the name that was passed in, and we're going to call set state on that object. I would recommend using this just out of safety. And the nice thing is if you call this and you pass it in the wrong name, it will, not error out. It won't crash your game. But if you wanted to add some debugs, then after this for loop, I would recommend putting a debug message like state not found and then printing out the name that was passed in. Because if a state was found, would have returned. But at least this way, when you're debugging your state machine, you can maybe find the errors more quickly. There's the quick overview of the state machine itself. I'm going to show you an implementation of this state and state machine in both the UI for the game Stop the Slime. So let's take a look at the state machine in action. Here we have the game state machine that will run the UI and some game logic. It has a child state, which has no script, but it's just looking for that just to make this stuff a little bit neater. Like you may want other child nodes of a state machine, so I wanted to cluster all the possible states in in its own little spot. So we have those. They're going to get loaded into the state machine. We're going to select splash loading state as the state to load. So let me just show you the state machine in action real quick. Load this up. Okay, you can see that the trees are raising. You have UI elements fading in. These are all handled by the state machine. And that fade in to black and then back is what I was talking about earlier with those pre-start and post-text. So we could go to like options, back, so the fade in and out. When we go in and you hit demo, there is a special thing that happens. I'm actually going to use that message dictionary and tell the level what settings the level should run at. So let's look at the code now for the state machine. So here's the splash loading state. First thing I'm doing is I'm getting all of its children and telling them to show. By default, they're all hidden. Then I'm calling the animation player and saying, hey, play this certain animation. You could do this through a signal, so I just chose not to in this case. Oh, one other thing. Whenever you're using these in your own custom class, you need to make sure to extend either simple state. So you need to make sure that you're calling the parent classes on start, on update, on exit. So one thing here, there's an error. This should be state update, but this is when you find errors when it's live. And in update, I'm just checking to see, hey, has the user clicked on the screen? If they clicked on the screen, then we're going to go to the next state. And here's an example of, this is an example of us going to the next state. I'm just getting a reference to the state machine. You could also use that reference that I previously showed you. Calling the change state function, pass it in the name of the state you want to go to. And in this case, I'm not using that message. So just passing an empty dictionary. And onExit's normally used for cleanup stuff. And that's exactly what I'm using it for here. I'm getting all the children and I'm telling them to hide. That way, whenever the next state opens up, those UI elements aren't showing up on the screen. Now let's look at the main menu state, because it's the one that has the big dictionary. So here it is. Whenever a button is pressed in the scene, it calls this function. And when that happens, we're going to get the state machine. We're going to call it change state, but this time, instead of a open and close curly bracket, I got some settings I want to tell the game about. We're going to say, hey, it was called from this. Just to tell it that maybe I want to do something different. in the game, whether they hit restart at the end of playing a game versus going from the main menu. That's why I'm telling you that. This is the scene to load. That way I could have different maps that will load depending on what button you press in the future. Of course, in this build of the game, it just has a demo button, but that's fine. This is what level it's going to be. Maybe I want to handle things differently if it's like above a certain level. And then this describes the waves. So if you haven't seen any of the previous devlogs, Stop the Slime is a tower defense game where you place towers to stop an invasion of slime in a kind of low poly medieval setting. So these numbers in this array are the type of slime. So 0 is the easiest slime to beat. 1 is a fast slime that's also easy to beat. Getting up to 2 is a kind of tanky boy that's also fast. And there is a 3. Okay, so 3 is this like giant orange slime that's very tanky. And this first number here is the time between spawning. So at first you start with a little bit more distance in between spawning and slime. Anyway, all of this isn't really important. What's important is just to give you the idea of what you could do by passing in a dictionary into the next state. But this was just an example of how you could use the dictionary. Well, I really hope this video was helpful for you. If you have any ideas for future tutorials, comment them down below. We will be using this state machine as kind of a base for other tutorials in the future, such as an AI machine gun turret, a player controller, and other such cool things like those. So if that kind of thing sounds interesting to you, and honestly, if you stuck around this long, you might as well hit subscribe and ring that bell, and I hope to see you next time.